Alright, it's Mr. Bernay. We're going to go over our next lesson, which is about exterior angles. So when you put this in your notebook, that's going to be the title, just like I have here. Exterior angles. And I'm going to give you a worksheet that looks like this. And the top part of it is for your notes, and the bottom part is also for your notes. But the first part I'll go over with you, and the second part you will do independently. So I've already cut this in half, so I made the cut right here with my scissors. So I have the top part here on the left hand side of your notebook, and the bottom part over here on the right side of your notebook. So let's take a look at each of those. Alright. So the top I have a definition of the exterior angle theorem. And it says that at each vertex of a triangle, and the vertex of a triangle is like on this triangle, S is a vertex, R is a vertex, T is a vertex. Vertex just means the place where the two lines come into contact. So basically it's the points here. These are the vertices, the vertex. So at each vertex of a triangle, the angle formed by one side of an extension of the other side is called an exterior angle of the triangle. So here is an example of an exterior angle. Alright, so the angle formed by one side of an extension and the other side, which is this side. This angle is called an exterior angle. For each exterior angle of the triangle, the remote interior angles are the interior angles that are not adjacent to that exterior angle. So these are the remote interior angles. In the diagram below, angle B, which is right here, angle B, and angle A are the remote interior angles for exterior angle DCB. When you see an angle listed like this, angle DCB, always the middle letter is the middle vertex of your angle. So angle DCB, C is the middle vertex. So angle DCB, it looks like this, DCB. So it's angle 1, also known as DCB. Alright, so this is this is like a fancy definition that's good to know, but not super practical for what we're doing. And I'll show you kind of an easy way to internalize this. This box here will be blank on your sheet, like this. You'll have to fill it in, so feel free to pause the video here to get that definition down. But the exterior angle theorem says that the measure of an exterior angle, so in other words, we're trying to find, like if this were if this weren't given like it is here, it just says angle 1. We're trying to find the measure of this angle. The measure of an exterior angle, this is an exterior angle, is equal to the sum of the measures of the two remote interior angles, which I said were angle B and angle A. So in other words, if you add these two angles up, B and A, you should get the angle 1 over here. So you can do it, that works, but I'll show you another way as well. Hopefully that some of you might want to use. Alright, so the exterior angle theorem says that if you add the two remote interior angles, which in this case is B and C, or B and A, if you add those together, you should get the measure of angle 1 over here, this exterior angle. So let's look at a couple of examples. First one says find the measure of angle 1. So angle 1 is this exterior angle here. So two ways that I'll show you to do it. One way is just like the theorem says. We could add up the remote interior angles here, which are 60 and 80. So that means that the measure of angle 1, 60, would equal 60 plus 80. So the measure, I forgot my 1 there. The measure of angle 1 is equal to 60 plus 80, which is also equal to 140 degrees. So that's one way to find this exterior angle here, is by adding up these remote interior angles, which are 60 degrees and 80 degrees. 60 and 80 make 140. The other way to think about it, which is kind of how my brain works, and this way you don't have to memorize that rule, is I look at this line here, or the side of this triangle made by R and T. I look at that as 180 degrees. If you combine these angles like that, it makes a half circle, so 180 degrees. All straight lines, which is what RT is, have an angle measurement of 180 because the angle here makes a half circle. So, since we know that this angle, RTS, and this angle, angle 1, add up to 180, then we know that if this angle here, RTS, equals 40, because we know that the angles of a triangle should add up to 180, 80 plus 60 plus 40 equals 180. If we know that this angle measurement is 40, we know that angle 1 will be 180 minus 40, which is 140. So it's also 140. So for me, I like to think about it this way. So these two angles together make 180, and then you subtract the amount of this angle here from 180 to find your exterior angle, angle 1 in this case. So I will start with that way on this problem, and then see if that makes sense to you guys. So the second example here, it says to find x. So here's x. Alright, so we're going to need to know a few things for this. So first of all, we need to know that this is a straight line here. And like I said before, all angles of a straight line equal 180. So that angle makes 180. So we know that 78 plus this angle has to make 180. So 78 plus 102 equals 180. So this angle here equals 102 degrees. So now we have two angles in this triangle. We have this angle here is 102. This angle here is 55. And we know that the three angles of a triangle have to add up to 180 degrees. We learned that from lesson 1. So now I can add up 102 plus 55, which is 157, and then subtract that amount from 180 degrees. So that is 23 degrees. So x equals 23 degrees. Alright, so all I did on that problem, since I know that this angle here, angle SQP, which is 78 degrees, and this angle here, SQR, they have to make 180 because it forms a straight line and it makes a half circle, the two angles together. So then I did 180 minus 78, got 102 for that angle there, angle SQR. And since I know that the angles of a triangle have to add up to 180, I added 102 plus 55 to get 157, and then subtracted that amount from 180 to find my missing angle x here, which was 23 degrees. Alright, so make sure you copy that all down into your notebook. Hopefully that makes sense to you all. And hopefully that can help you with the homework that is here. And again, I say it's homework, but really I want you to practice these exercises in class and to have those examples in your notebook to use as a resource. So I'll give you some hints for these. It says the directions say to find the measures of each numbered angle. So on this one, you're looking for this angle. So you can either add up the two remote interior angles, or you can find this angle first by thinking about what number plus 50 plus 65 will equal 180, because that's the angles of a triangle should equal 180, and then taking that amount subtracted from 180 to find this angle 1, whichever way you'd like to do it. Similar over here, you probably would want to find angle 2 first, and then find angle 1. Over here, this is kind of different. You might be able to see this right away, but these two triangles, the two triangles that form this parallelogram are equivalent triangles. And the reason you know that is because you see these hash marks here. That's saying that these two sides are equivalent and these two sides are equivalent. So since the side lengths are equivalent, that automatically means that their angle measurements will be equivalent as well. So if you know the angle measurements here, you should be able to find the angle measurements for angles 1 and 2, and then you'll be able to use those angle measurements to find this measure number 3 over here. Alright, and good luck, and let me know if you have questions. I'd be glad to help. Make sure you get this all down in your notebook. Thanks.